Once again, I welcome you all to the discussions of a new chapter from the syllabus of Class 11 Physics. The name of the chapter is Mechanical Properties of Solids. As the title of the chapter itself states, we shall be discussing some very important properties regarding mechanics of solids. A rigid body generally means a hard solid object having a definite shape and size. But in reality, bodies can be stretched, compressed, and bent. Even the appreciably rigid steel bar can be deformed when a sufficiently large external force is applied on it. This means that solid bodies are not perfectly rigid. A solid has definite shape and size. Now, in order to change or deform the shape and size of a body, a force is required. This force is called a deforming force. Now, how to define it? A force that produces a change in shape or size of an object on applying it. Now, whenever a deforming force is applied on any object, there are two possibilities. Either the object will get permanently deformed. This means it will be completely unable to regain its original configuration. Or, in the second case, the object will regain its original configuration after the removal of the deforming force. So, accordingly, we can think of two different properties. And as you can see right now on your screen, the two different properties are elasticity and plasticity. So, what is elasticity? It is that property by virtue of which a body regains its original configuration after removal of deforming force. For example, if we stretch a rubber band and release it, it snaps back to its original length. Coming to the other property, plasticity. Now, if a body does not regain its original size and shape completely and immediately after the removal of the deforming force, so it is that property by virtue of which a body is or a body does not regain its original configuration on removal of deforming force. So, very quickly, we can cite the differences between an elastic deformation and a plastic deformation. So let me just zoom this picture for you all so that it is properly visible to you all. Elastic deformation is the deformation that disappears upon the removal of the external forces, causing the alteration and the stress associated with it. Whereas in case of plastic deformation, there is a permanent deformation or change in shape of a solid body without fracture under the action of a sustained force. Elastic deformation is reversible. This means we can get back the original shape and size of the body, whereas a plastic deformation is permanent, that is, it is irreversible. Elastic deformation, as I said, it is non-permanent. The substance can resume the initial state back, whereas the plastic deformation is permanent. The substance stays unchanged after removing the stress. In case of elastic deformation, it causes the chemical bonds of the substance to undergo stretching and bending. But in case of plastic deformation, some of the chemical bonds of the substance can undergo breakage, due to which the change is permanent. Now, last but not the least, in case of an elastic deformation, atoms do not slip pass on each other, but in case of plastic deformation, atoms slip pass on each other. Perfectly elastic body. Those bodies which regain its original configuration immediately and completely after the removal of deforming force are called perfectly elastic bodies. The nearest approach to a perfectly elastic body is quartz fiber. So, what is a perfectly plastic body? That body which does not regain its original configuration at all on the removal of the deforming force are called perfectly plastic bodies. So, putty and paraffin wax are nearly perfectly plastic bodies. Let us now understand a very important concept: stress. If a body gets deformed under the action of an external force, then at each section of the body, an internal force of reaction is set up, which tends to restore the body into its original state. So, the internal restoring force set up per unit area of cross section of the deformed body is called stress. So we can say that stress is equal to applied force divided by area. Its SI unit is Newton per meter square or Pascal. Let's discuss about the types of stress. So, there are three different types of stress. What are they? The first one being longitudinal stress. If deforming force is applied normal to the area of cross section, then the stress is called longitudinal stress. Now it is further categorized into two types. The first one being tensile stress, and the second one being compressional stress. Now, what is tensile stress? If there is an increase in length of the object under the effect of applied force, then stress is called tensile stress. On the other hand, if there is a decrease in length of the object under the effect of applied force, then stress is called compressional stress. Coming to the second group, the second is tangential or shearing stress. If deforming force acts tangentially to the surface of a body, it produces a change in the shape of the body. The tangential force applied per unit area is called tangential stress. Coming to the last one, it is normal stress. If a body is subjected to a uniform force from all sides, then the corresponding stress is called normal stress. So these are the different types of stress built up in any object. Strain. When a deforming force acts on a body, the body undergoes a change in its shape and size. The fractional change in configuration is called strain. So, what should be the mathematical representation? Mathematical equation for strain is strain equal to change in dimension divided by original dimension. Just like stress, we can have different types of strain. Now, first of all, I would like to tell you that strain has no unit and it is a dimensionless quantity. According to the change in configuration, the strain too is of three types. So we can talk about longitudinal strain, that is equal to change in length divided by original length. We can have volumetric strain, which is equal to change in volume divided by original volume, and then we can have shearing strain, that is equal to tangential applied force divided by area of the face. So now we shall understand what is Hooke's law. Robert Hooke found this important law that gives the relationship between the force applied to an unstretched spring and the amount the spring is stretched. Now, according to Hooke's law, within the elastic limit, the stress is directly proportional to strain. So we have stress directly proportional to strain, or we can write down stress to be equal to a constant times strain, where constant K is called the elastic modulus of the material. So up till this much we will keep today's lesson. We shall resume from the same law and understand different concepts in our next class. Thank you.